The F-16 Block 70 undergoes dynamic functional testing, ensuring mission readiness through precision engineering and rigorous hydraulic pressure analysis.
As you can see here, the density gradient is perfectly uniform, no inclusions whatsoever.
Excellent. This confirms it meets the F-16 standard.
Thermal stability achieved. The stress factors look good.
Confirmed. The retraction cycle data aligns perfectly.
The robotic CMM probe verifies the internal geometry with sub-micron accuracy, crucial for the F-16's reliability. This internal plumbing is crucial for the controlled speed and sequencing of the F-16 Block 70 Viper's landing gear during retraction cycle testing.
RFID scan complete. Batch code matches the manifest for the F-16 system.
Macro analysis shows 0 surface abnormalities. We are clear for plating.
The torque on bearing 3 is stabilizing.
Readout confirms 95 kilonewton meters.
Press fit is within tolerance.
These sensors provide the critical feedback to the flight control computer, confirming the gear's exact position during retraction cycle testing.
Interlocks engaged on all points.
Confirmed. E-stops are green, ready for initial cycle.
Cycle complete. Data signatures verified against the blueprint.
Perfect retraction, no load.
Trends. Massive pneumatic actuators apply several tons of force, simulating a high-speed landing impact. Engine
The piston rod is submerged into the chromic acid solution. This high current process ensures a perfectly uniform layer of hard chrome. High-purity deionized water removes all traces of the chromic acid, followed by a vacuum chamber process to remove any trapped hydrogen.
The chrome-plated nose gear piston rod is mounted onto a specialized cylindrical grinding machine, a high-speed diamond grind.
Robotic dispensing systems apply a thin layer of lubrication grease to the seal surfaces, preparing them for installation.
Utilizing controlled pressure, the robotic press inserts the pre-lubricated seals, followed by the slow insertion of
With process A complete, the focus shifts to the nose gear.
Alignment markings are good. Confirmed. Torque values are within tolerance.
Torque wrench set to specification.
Confirmed. Pressure holding steady at 3,000 psi.
Reading 32,000.
Confirmed. The strut clears the door with zero interference.
Retraction cycle test, final confirmation. Area clear.
Confirmed. Proceeding with hydraulic activation in 5.
F-16 Viper, process B. Hydraulics armed. Retraction sequence initiated.
The data confirms optimal performance. We have a smooth pressure curve and perfect synchronization across all sensors.
Gear down. Emergency cycle activated. We have a confirmed downlock.
bypass sequence initiated. Hydraulic pressure failure confirmed.
Emergency deployment successful. Gear is down and locked. System verified.
"100 cycles complete, and we have a definitive pass."
Well done, team.
Keep an eye out for particulates in the fluid.
Sample secure. I see no signs of metal wear or seal degradation yet.
We have full weight on the nose gear. Checking center of gravity now.
Stability confirmed. Process B successful.
Tow bar attached and secured. Copy.
Roger that. Initiating tow sequence now.
This marks the conclusion of component-level manufacturing, leading directly into the final customer usage phase.
Ground, confirm process B is nominal, requesting high-speed taxi.
Roger. Viper 1. Process B confirmed. Cleared for high-speed run.
Gear up. 5 minutes. We're on us. Landing gear retraction complete. Status screen, gear up and locked. Process B confirmed.
Gear down.
Viper 7-0, gear cycle complete, taxiing to spot.
Roger that. Viper 7-0, clear to park. Well done.
Final usage check on the NLG strut. No fluid leakage, pitting, or scoring. Confirmed process B successful. Check cycle complete. Gear is green.
Confirmed. Ready for certification.